Designate one of the pipes as the feeding pipe and cut the bottom at a 45-degree angle so that the food waste you put in can slide out easily into the bottom of the tank. This gives the pipe a pointy end. Sand any rough edges and soap up the pipe and the inner ring of the uniseal, and firmly push the pipe through the uniseal, twisting as you go, until it reaches the bottom of the tank and stops. Designate the second of your 3 pipes as the gas outlet pipe, and cut a hole so that it will be just below the top of the digester when inserted through the second uniseal and pushed to the bottom. Yes, you'll have to measure this one, as the heights of your IBC can vary. You can do this by putting the pipe in the hole before you put the uniseal in and making a mark with a permanent marker about 2 centimeters below the place where the top of the tank touches the pipe. Make sure you sand the edges of this hole smooth and flush so it doesn't cut or get stuck on the uniseal on the way down. Then push the gas outlet pipe into the tank through the uniseal. We like to put the feeding pipe and the gas outlet pipe on the same side of the digester, as we find that this is where most of the food settles and most of the gas rises and collects. Designate the third of your 2-inch pipes, the slurry or effluent pipe, where the rich organic liquid fertilizer or compost tea will exit. We cut a hole in this last pipe. Make sure you also sand the edges of this hole smooth and flush so it doesn't cut or get stuck in the uniseal on the way down, so that when it's pushed down to the bottom through the uniseal, the hole will be somewhere near the middle of the tank. We do this because bioactive solids are being digested at the bottom of the tank, mostly carbs and protein, while lipids, oils, and fats will rise and be digested at the top of the tank, and we don't want to remove feedstock that is still energy-rich. By placing the outflow pipe on the opposite side of the tank, diagonally across from the feeding pipe, we maximize the hydraulic retention time of the feeding material, that is, the time it spends being digested in the tank, so we can win the maximum amount of energy from it. Since our digesters are a kind of plug-flow digester design, the food we push in one side of the tank is slowly shoved to the other side of the tank when new material is added. But the fertilizer we force out with each feeding has had the best opportunity to get digested, and because we draw it from the middle of the far end of the tank, it comes out as a liquid that is nitrogen and nutrient-rich, but doesn't clog pipes. The sludge can stay in for years and years, and only rarely needs to be pumped out to make a solid compost. With these 3 pipes in place, you're basically done with the digester. The rest is plumbing.